Parts of the Carolina coast are already underwater. Some towns just picked up more rain in a single day than they normally see across 2 full months of summer. And this flooding disaster is only the opening act. The exact same stuck weather pattern that's drowning the East Coast right now is about to trap dangerous heat over the middle of the country and fire off round after round of severe storms across those same regions for days on end. Here's how one jammed-up weather system is managing to do all of it at once. Weather patterns like this don't announce themselves clearly in advance. They build slowly, over days, as pieces of the atmosphere that would normally keep moving simply stop moving instead. And by the time the public actually notices what's happening, usually because a town is flooded or a heat warning has gone out, the pattern is already well established and already loaded with the ingredients for whatever comes next. That's exactly the situation unfolding right now, and understanding the full shape of it matters just as much as watching any single day's forecast. A slow-motion flooding disaster. Right now, as I'm putting this together, a slow-motion flooding disaster is unfolding across central North Carolina and up into Virginia, and the rain hasn't fully let up yet. It's been falling in waves since earlier this week, pouring through the night and continuing straight into daylight hours across the Piedmont region and the coast alike. Forecasters placed a corridor stretching from southeastern Virginia down through the Outer Banks under a level 3 out of 4 flash flood risk, one of the higher tiers on the scale they use for this kind of event. That risk was expected to hold through the day before easing slightly afterward, with forecasters noting there was still a real chance it could get bumped back up again, depending on exactly how much additional rain fell in the meantime. A level 3 risk isn't a routine call to make. It means forecasters expect the kind of rainfall that produces widespread, genuinely dangerous flooding. And that's exactly what's been happening on the ground. High Point saw more than 6 inches of rainfall by early morning. Durham picked up over 3 inches, with spots in nearby Hillsborough topping 4. Roads have flooded across Wake County. Trees have come down onto homes and power lines. And thousands of customers across the Triangle region have lost electricity as saturated ground gave way under the weight of falling limbs. What makes this particularly jarring for a lot of residents is that much of central North Carolina had actually been dealing with drought conditions just weeks earlier, meaning the region has swung from worrying about dry ground to bracing for dangerous flash flooding in a remarkably short window of time. Bigger than one bad day of weather. Here's the part that matters most, and it's the reason this story is bigger than just one bad day of weather. What's hitting the Carolinas and Virginia right now isn't a single storm that rolls through and clears out by evening. It's the leading edge of a weather pattern that has essentially locked itself into place over a huge stretch of the country, and that pattern is about to do something unusual over the coming days. Today, it's drowning the Carolinas. In the very near future, that same pattern is going to trap a dangerous dome of heat over the middle of the country and set off wave after wave of severe storms across those same general regions. Before we get into what comes next, it helps to understand exactly what's happening right now, because emergency officials are actively telling people in low-lying areas to stay off flooded roads and move to higher ground while this is being recorded. It also helps to understand what these flood risk levels actually mean, because forecasters don't hand out a level 3 warning casually. That particular tier is reserved for days when meteorologists expect numerous flash floods, the kind that overwhelm creeks and storm drains and turn low spots into standing water fast enough to trap people inside their cars or homes. When that level of risk gets placed over a corridor stretching from the Virginia coast down through the Outer Banks, forecasters are telling you, in advance, that they expect a widespread, genuinely dangerous event, not some isolated, easily avoided problem. That was the call made earlier this week, and the rain has largely verified almost exactly what was predicted. Moisture from hundreds of miles away. There's also a strange twist buried in this story that catches a lot of people off guard, because much of the moisture actually driving this flooding didn't originate anywhere near the Carolinas at all. It traces back to a tropical storm that made landfall hundreds of miles away, near the Gulf Coast. Tropical storm. Bertha came ashore near New Orleans earlier this week as a weak, disorganized system with winds only around 45 miles per hour, then drifted back out over open water before pushing toward a second landfall closer to the Texas coast. By any measure of raw wind speed, Bertha stayed a genuinely weak storm the entire time, and it was never expected to strengthen into a hurricane. But here's the thing about a storm like that. Even a weak, falling-apart tropical system carries an enormous reservoir of moisture, and that moisture doesn't simply stay locked around the storm zone center. A stalled frontal boundary sitting across the eastern part of the country has been reaching down and pulling that deep, Gulf-sourced moisture hundreds of miles inland, straight into the Carolinas and Virginia. So the worst flooding isn't happening anywhere near where Bertha's own center was spinning. It's happening close to 1,000 miles away, fed entirely by moisture the storm released as it fell apart. That's one of the more counterintuitive facts in meteorology. A weak, disorganized tropical storm can sometimes end up more dangerous for people far inland than a stronger, tighter hurricane would have been, precisely because its moisture gets spread out across half the country instead of staying wrapped tightly around one coastal landfall point. Weather forecasters even pointed out this exact connection this week, noting that while Bertha itself sat well to the west of North Carolina, the storm was actively helping funnel deep tropical moisture straight into the Carolinas, even from that distance. It's a good reminder that a storm's official forecast track on a map doesn't always tell you where its real impacts are actually going to land. Sometimes the worst weather shows up nowhere near the storm symbol itself. It's worth pointing out just how unusual this particular storm's behavior has been from the start. Bertha struggled against unfavorable upper-level winds for essentially its entire life cycle, staying lopsided and poorly organized, even while sitting over near record-warm Gulf water that, under different conditions, might have allowed it to strengthen considerably. That structural weakness is exactly why its winds stayed modest throughout, even as its rain output became genuinely significant somewhere else entirely. Meteorologists sometimes describe this kind of storm as all rain, no wind, and it's a category that tends to get underestimated by the public precisely because the storm itself never earns the dramatic hurricane label that usually triggers widespread attention. The jet stream is the engine. To understand why any of this is happening at all, you have to look up the jet stream, because the jet stream is really the engine driving this entire week of weather. Under normal conditions, the jet stream moves storm systems along at a fairly steady pace, and a heavy rain event passes through an area in a matter of hours before sliding off to the east. Right now, though, the jet stream has buckled into a large, slow-moving wave, and the fronts and storm systems riding inside that wave have essentially stalled in place. There's a stalled frontal boundary draped across the eastern part of the country, and it's acting almost like a fixed line that keeps generating storm after storm along the exact same path. Meteorologists call this training, where individual storms form and then move parallel to the boundary, crossing over the same towns again and again, almost like train cars rolling down the same track. Training is one of the most efficient ways the atmosphere produces extreme rainfall totals, because the total accumulation at any single spot isn't just one storm's worth of rain. It's hours of storms stacked directly on top of each other in sequence. It's genuinely the difference between a normal summer downpour that soaks a town for 20 minutes and moves on, and a flash flood emergency that keeps dropping water on the same handful of neighborhoods for hour after hour, without any real break in between. This stalled pattern isn't brand new either, which is part of why the ground was primed to flood so quickly once the heaviest rain arrived. The same broad dip in the jet stream sitting over the middle and eastern parts of the country had already produced rounds of severe weather and serious flooding across this same general region in the days leading up to this latest event, meaning the soil across parts of the Carolinas and Virginia was already saturated before this newest round of rain even began falling. That's a big part of why relatively modest rainfall totals have been producing outsized flooding impacts. The ground simply has nowhere left to send the water. Scarred mountains, elevated risk. There's also a genuinely alarming layer to this story tied to where some of the heaviest rain is falling in the mountains. Areas in and around the Blue Ridge and the wider southern Appalachians have been picking up meaningful rainfall on top of ground that still hasn't fully healed from Hurricane Helene's catastrophic flooding back in 2024, when entire river valleys were reshaped, roads were wiped out, and hillsides across western North Carolina were left severely destabilized. That kind of damage doesn't simply heal once the immediate disaster passes. It leaves behind loosened slopes, altered drainage patterns, and terrain that's dramatically more likely to fail the next time heavy rain arrives. So, when additional rounds of rainfall fall on ground that's still scarred from that earlier disaster, the resulting flash flood and landslide risk is elevated well beyond what the raw rainfall numbers alone would suggest. Mountains make everything about flooding worse in a way flat land simply doesn't. Rain falling across a slope doesn't soak in evenly. It funnels downhill into narrow valleys and stream beds, gathering speed and volume as it goes. So a stream that looks like a gentle trickle in the morning can turn into a wall of water by afternoon. Add in leftover debris, downed trees, and soil that was already loosened by the earlier disaster, and you get exactly the kind of fast-moving, destructive flooding that has proven so deadly in these same mountains before. Communities across that part of western North Carolina know exactly what that looks like, from painful recent experience, which is why forecasters have been especially insistent about people in those zones turning around rather than attempting to drive through any flooded road. And why the warnings this time around carry an extra weight for a community that's essentially being asked to relive a nightmare on ground that hasn't finished recovering from the last one. One machine, two disasters. Now step back for a second, because this is really the idea that ties this entire week together. What's flooding the Carolinas and Virginia right now isn't some standalone, isolated weather event. It's one output of a single stuck weather pattern. And that same pattern is about to produce a completely different kind of disaster in a completely different part of the country. The same jammed configuration holding a front in place over the southeast, is also busy building a large dome of high pressure over the middle of the nation. And it's setting up a corridor for severe storms that will keep firing along its edge for days. Think of it as one machine producing two separate outputs. On one side, over the east, the pattern has been wringing tropical moisture out over already saturated ground and flooding it. On the other side, over the middle of the country, that same pattern is trapping heat and quietly building up the fuel for a fresh round of severe thunderstorms. Heat, flooding, and violent storms sound like three separate stories, but they're really one single story, driven by the same stalled jet stream that has simply refused to move on. The heat dome is already here. And in fact, that heat dome isn't some distant future risk. It's already been building hard over the last several days. A massive area of high pressure has taken hold across a huge stretch of the country, stretching from around Minneapolis down through New Orleans, and from Kansas City over toward Cleveland. It pushed nearly 100 million Americans under some form of extreme heat warning, watch, or advisory earlier this week, with tens of millions of those people placed in the higher major to extreme tiers of heat risk, stretching from the deep south through the Great Lakes and into the mid-Atlantic. Kansas City alone has seen heat index values climbing into the range of 106 to 107 degrees, with an extreme heat warning in place there, and highs across parts of Texas, Arkansas, and Louisiana have been pushing to or above the 100-degree mark. That oppressive heat has been expanding steadily into the Midwest and Great Lakes as the underlying ridge strengthens and shows little sign of breaking down on its own. A heat dome works by trapping a strong ridge of high pressure in the upper atmosphere. Underneath it, the air sinks, compresses, and warms even further. That sinking air suppresses clouds and rainfall, which is exactly why the middle of the country has been baking under mostly clear skies, even as the East Coast drowns under nearly continuous rain. Why the heat and the storms are actually connected. But here's the part that ties the heat directly to the coming severe weather threat, and it's the key to understanding why these two seemingly separate disasters are actually connected. A strong ridge acts almost like a boulder sitting in the middle of a stream. Disturbances riding along in the jet stream can't punch straight through it, so they get forced to ride up and over its northern edge instead. That northern edge becomes a kind of highway, where warm, unstable, moisture-loaded air at the surface collides with disturbances passing overhead. And that collision is exactly what organizes severe thunderstorms right along the rim of the dome. So a heat dome is never purely a heat story on its own. It's also the steering feature aiming round after round of severe weather at the northern and eastern edges of the country. The heat itself deserves serious respect on its own terms too, because heat quietly ranks as the deadliest form of severe weather in the country most years, outpacing tornadoes, hurricanes, and floods combined for total fatalities. A dangerous, prolonged heat wave settling over the plains and Midwest at the peak of summer isn't just uncomfortable. It stresses power grids as air conditioners run nonstop. It endangers anyone without reliable access to cooling. It becomes especially dangerous once overnight temperatures stay elevated. The body never gets a real chance to recover before the next scorching day begins. Part of what makes heat so consistently underestimated as a hazard is how quietly it operates compared to something like a tornado or a flash flood. There's no dramatic footage of a heat wave, no wall of water or debris field for news cameras to capture. The damage instead shows up gradually in hospital admissions, in strained emergency rooms, and in a rising count of deaths that often isn't fully tallied until weeks or months after the fact. That invisibility is exactly why public health officials tend to push so hard on basic precautions during events like this one. Check on elderly relatives, never leave anyone in a parked vehicle even briefly, and take symptoms like dizziness or confusion in the heat seriously rather than assuming they'll pass on their own. Charging the battery for the next round of storms. A heat dome doesn't simply sit there harmlessly either, even on the calm, blue sky days in between storms. Every hot, humid, sun-baked day loads the lower atmosphere with more instability and more available fuel. When a disturbance eventually rounds the top of that ridge, all of that stored energy gets converted directly into the ingredients for violent thunderstorms. In other words, the very same feature baking the plains all week is simultaneously charging the battery for the storms that fire along its edge. Severe weather has already been rolling through parts of the Midwest and Great Lakes recently, with cities like Milwaukee, Green Bay, Chicago, and Minneapolis facing threats of damaging winds, large hail, and even tornadoes as disturbances ride along the northern rim of this heat dome. And this is very likely not a one-time event. A pattern this stuck doesn't typically break down on any convenient schedule, and current forecast guidance suggests it may simply keep recharging, sending additional rounds of severe weather sweeping across the Midwest, the Ohio Valley, and the Northeast in the days ahead, largely following similar paths each time the pattern reloads. Compounding damage round after round. There's a real cumulative danger that comes with getting hit by disturbance after disturbance, riding along the same stuck pattern. A first round of storms knocks down trees and power lines and leaves repair crews stretched thin. A second round then hits communities that are already cleaning up debris, already dealing with power outages, already sitting on saturated ground. By the time a third round arrives, rivers are running high, the ground has no capacity left to absorb more water, and the overall tolerance for any additional wind or rain has essentially disappeared. A pattern capable of delivering several organized severe weather days to the same general corridor isn't simply 3 times as bad as a single storm passing through. The impacts genuinely compound on top of each other, which is exactly what makes a stuck weather pattern like this one so much more dangerous than any single storm ever could be on its own. Emergency crews in some of the hardest hit areas are already dealing with exactly this kind of layered exhaustion, still clearing debris and restoring power from earlier rounds of severe weather, even as fresh warnings go out for the next system moving in behind it, which stretches already thin resources even further and slows down recovery efforts across the board. Uncertainty is itself the warning. Here's what deserves your attention looking further ahead. The farther out forecasters try to look past the next couple of days, the more that confidence naturally drops, and that growing uncertainty is itself worth paying attention to. A pattern this deeply stuck rarely breaks down neatly or on a convenient timeline. Current guidance suggests it may simply keep reloading, continuing to send waves of severe weather toward the Midwest, the Ohio Valley, and the Northeast, even beyond what forecasters can currently pin down with real confidence. That's really the unsettling core of this entire setup. Every time this pattern recharges, it tends to aim at ground it has already worked over before, regions it has already soaked with rain, or regions it has already battered with severe storms. The flooding currently unfolding across the East Coast is really just the opening move. The heat and the multi-day severe weather corridor building across the middle of the country represent the next act. And because forecasters genuinely can't yet say with confidence when this pattern will finally break down and move on, it would be a mistake to assume there won't be a third act layered on top of that. Why stalled patterns like this keep happening? None of this is entirely new behavior for the atmosphere, even if each individual event feels unique while it's unfolding. Meteorologists have documented a broader tendency in recent decades toward what's sometimes called blocking, where the jet stream buckles into a large, slow-moving wave and effectively parks weather systems in place for days at a time, rather than letting them slide through on their usual schedule. Some of the most damaging flood events in recent American history, from catastrophic rainfall in Texas to historic flooding in the Northeast, have shared this same underlying fingerprint. Not necessarily record-breaking storm intensity, but a storm system that simply refused to leave, dumping hours of rain on the same handful of communities, instead of spreading that same total rainfall out across a wider area over a longer stretch of time. That pattern of behavior is exactly why meteorologists have grown increasingly cautious about treating any single storm in isolation. A storm that might otherwise be entirely survivable can become genuinely dangerous purely because of how long it lingers, rather than how strong its winds happen to be at any given moment. This week's setup fits that same mold closely enough that forecasters have been unusually direct in their public messaging, treating the stalled pattern itself, not any single storm cell, as the actual story worth tracking. What actually matters? If this affects you. So here's what actually matters if any of this affects you directly. If you're in the Carolinas or Virginia right now, this flooding threat hasn't fully passed. Even once the heaviest rain eases, the ground stays saturated and rivers and creeks can keep rising for a while afterward, meaning it doesn't take much additional rain to push already flooded areas over the edge. Never drive through water covering a road, since moving water only a foot or two deep is enough to sweep a car off the pavement. And most people who die in these flooding events die inside their own vehicles. After underestimating water, they thought they could cross safely. If you live in a low-lying area anywhere along this corridor, keep paying close attention to local alerts over the coming days, and make sure you actually have a way to receive those alerts overnight, since a surprising number of these flash flood emergencies develop after dark, when people are least likely to be checking the news. And if you live anywhere across the Midwest, the Great Lakes, the Ohio Valley, or the Northeast, now is genuinely the time to make sure you know exactly how you'll receive severe weather warnings before storms actually arrive, rather than scrambling to figure it out once the sky has already turned dark and the sirens are going off. It's also worth checking on elderly neighbors or relatives anywhere under that extreme heat warning umbrella, since heat-related illness can develop quietly and quickly, especially for anyone without reliable air conditioning or a way to cool down overnight. The single most important question right now isn't really what any one individual storm ends up doing. It's when this entire stuck weather pattern finally lets go. And until it does, the same regions across this country are going to keep absorbing hit after hit from a weather system that, for now, simply refuses to move. Keeping track of this as it develops, Patterns like this one tend to earn a lot of attention in their opening days and then quietly fade from the news cycle well before they actually resolve, simply because the initial dramatic flooding footage stops generating headlines even while the underlying risk is still very much active. That gap between media attention and actual ongoing risk is worth being aware of on its own. The most dangerous phase of a stuck pattern isn't always the opening flood event that makes national news. Sometimes it's the third or fourth round of severe weather several days later, hitting communities that have quietly stopped paying close attention because the story already feels like old news. That's exactly why it's worth checking back on this story periodically over the coming days, rather than assuming the danger has passed simply because the initial coverage has moved on to something else. A jet stream pattern this deeply entrenched doesn't reliably announce its own ending in advance. And the safest approach is simply to keep watching the forecast for your specific region until local meteorologists themselves say the pattern has finally broken down and moved along.